Hi, I'm Sachin. I'll be solving problem 2 of homework 5 of the course EL6303. So we've been given fx of y is equal to a divided by y square x, where y is greater than 1 and x is defined in the range 1 by y and y. So the first sub question says, draw the non-zero definition region of fx of y. So basically fx of y, which is defined in the non-zero range. So it's given that x is less than y. So let's represent that by a straight line, because we know that y is equal to x in this line, so x is always less than y. So if x is less than y, so it's in these areas, and it's given that x is greater than 1 by y, so it's defined in this interval. X greater than 1 by y is this graph. So basically we are plotting the ranges where the x lies. So that becomes x less than y is here and x is greater than 1 by y lies here. So this is the first sub question. So in the second sub question we have find a such that fx of y is a joint distribution function. So we know that in order to fx of y to be a joint distribution function, integral of the area f x y dx dy should be equal to 1. So let's find what the area is. So we have x ranging from y to 1 by y and y ranging from 1 to infinity dx dy. So because y limit is from 1 to infinity and x is from y to 1 by y, so we have 1 to infinity a by y square into 1 by y into y, 1 by x dx dy. Why is it 1 by x dx dy? Because it's defined in this region. So 1 to infinity a by y square, integral of 1 by x is ln y, ln x. So putting in the region of interest as y 1 and 1 by y, we have ln y minus ln of 1 by y dy is equal to 1. So we have 2a. So 2a into 1 to infinity ln y divided by y square dy is equal to 1. So now let's integrate this integral by using integral by parts. So let's put u as ln v and dv as 1 by y square dy. So du becomes 1 by y and v is equal to integral of this. Integral of this is minus 1 by y. So integrating by parts, 2a into uv is minus ln y by y plus v du, integral 1 by y square dy should be equal to 1. 2a into minus ln y minus 1 by y is equal to 1. So minus 2a into ln of y plus 1 divided by y from the limits 1 to infinity becomes 1. So minus 2a, suppose we substitute the value of y as infinity, so this becomes 0. 1 by infinity is 0, so 0 minus ln 1 is 0 by 1 by 1, so 0 minus 1 is equal to 1. So 2a becomes 1, a is equal to half. So we get a to be equal to half. So this third sub question says find and draw marginal density function fx of x and fy of y. So how do we calculate fx of x? So fx of x is minus infinity to infinity fx of y x of y in the dy. Why is it dy here? Because if we integrate with respect to dy, we get only the x constant, x terms remaining in the function, so that becomes fx of x. So fx of x is minus infinity to infinity a by y square x dy. So putting the limits minus infinity to infinity a by x into 1 by y square dy. So 1 by 2x integral minus infinity to infinity 1 by y square dy. So but y is only defined in the range 1 to infinity. So 1 by 2x integral minus y 1 to. So now we get fx of x to be equal to 1 by 2x. So similarly we find fy of y similarly in the ranges fx of y into dx. Again it's dx because we only concentrating on the y term here. So integrating from 1 by y to y, because 1 by y less than x less than y, so integrating in this region we get fy of y as ln y by y square. So the graph of fx of x and fy of y will look 1 by 2x will look at this, and fy of y will be in this region. And now the fourth question asks whether fx of x and fy of y are valid density function. So it is valid density function if in the range 1 to minus infinity to infinity the function is equal to 1. So let's just check that. So 1 to infinity ln y dy by y square, how much is it? So integrating by parts again we get I is equal to 1, so thus it's a valid density function. Thank you.